Hi guys, this is Chetan. In this video, I'm going to show how to set up a VPN connection in AWS. So if you already seen a video around this, this is a new version of the video and there are some improvements with respect to how AWS improved, and there are some extended version of the connectivity which I'll be talking about in the later section of this video. Um, so just a quick recap. As you know, if you have to set up an connection between AWS and your on-premises network, then in AWS there are two options. First is setting up the IPsec VPN connection between AWS VPC and on-premises network. Now IPsec VPN works, or the traffic flows over through the internet and it is encrypted. That's where both the networks can communicate over a secure channel. So most of the small companies or medium-sized companies would prefer VPN connection because it is easy to set up. It hardly takes few minutes to set it up. And then you can communicate between these two networks seamlessly over private IP addresses. Other option is AWS Direct Connect, where it's a point-to-point physical connection between AWS data center and on-premises network. We are not going to see Direct Connect in this video, but we are going to see how to set up an AWS VPN connection. So going back to this diagram, you can see on AWS side we have VPC and we have virtual private gateway, which will act as an AWS side of the router. On the right side, which is on-premises network, we call it, we need a router, we call it customer gateway, and this customer gateway needs to be accessed over the internet. That means it should have a public IP on this side. Now as we have access to AWS account, we can set up the left side of this network into AWS, any of the region of your choice. But we don't really have access to this side, right? And that's where in order to do this lab, we need to have a simulated corporate network. And if you can see, I can simulate this network using AWS itself. So what we can do is we can take another AWS VPC in another region and we can use a router here. Now if you say in the real world, people will use well-known routers like a Cisco or a Juniper or Palo Alto firewalls to set up these VPN connections, but we want to do it with minimal cost, and that's where we are going to set up this router on, in fact, EC2 instance using OpenSWAN software. So if I talk about the network diagram in AWS, this will look something like this. On left side we have AWS network, on the right side it's simulated corporate network. Now in this network, if you see, I don't need to have this EC2 instance to be accessible over the internet. That means in this VPC I would just have a private subnet and one EC2 instance which would have just a private IP address. However, on the right side, this is a simulated network. As I said, we would have VPC and we would have public subnet. Now why public? Because we actually want to launch an EC2 instance here and configure OpenSWAN on this instance. So we would have to connect to this instance over an internet and then configure OpenSWAN. That's where we need it in a public subnet. Now if you see this diagram, one thing is we can't really reach to this EC2 instance directly from over the internet. There is no internet gateway and this is a private subnet. That means the only way we can reach to this instance is from this instance, and that too when we have this VPN connection established. So how AWS VPN works, on AWS side of the network we need something called virtual private gateway, VPG or VGW. And on right side we need a customer gateway, which in our case is this EC2 instance having the OpenSWAN VPN software. Okay, so in order to do these labs, you will have to set up two VPCs. For this exercise I have chosen Mumbai region as for AWS side of the VPN connection, and North Virginia region to simulate the corporate network. So the first thing would be to create two VPCs, create one private subnet here in Mumbai region and one public subnet in North Virginia region. Then we'll launch two EC2 instances, one private, one public. We'll create a virtual private gateway, and we would have to modify routes. We have to do a lot of things that I'll walk you through while we do this exercise. So for simplicity, or for you guys, what I have done is I have created a doc which talks about each and every step in order to set up this VPN connection. And if you follow this blog document till the end, you should be able to set up a VPN connection on your own. So let's jump into the action, and let's implement the VPN connection. So as you can see, I need to create two VPCs. I have defined these CIDR ranges as well. So let me do the same thing. So first thing, I'm going to create two VPCs in two different AWS regions. So let me go back to my AWS console. I have this console. Let me close some windows. I'm in Mumbai region. You can see I have one default VPC. I'm going to create a new VPC. Let's call it VPC A with the CIDR range 10.100.0.0.16. Rest of the things I'm keeping default. Now in this VPC, I just need a private subnet. Again, look at the diagram and just follow the instructions which are written in the document. So I'm going to the subnet. I'm creating a subnet. Let me call this subnet VPC A private subnet. And AZ, you can select anything. In Mumbai region, T2 micro instances are not supported in AZ3, so I need to select anything other than AZ3. And the CIDR range, I'm choosing 10.100.0.0.24. If you are not sure how to calculate these CIDRs, just refer to my video basics of VPC. Let's create this subnet. Now along with the subnet, it always create a route table. Don't use default route table because then you won't understand what's happening. So let me create a route table. Let me call it VPC A. This is a private route table, and once I create the route table, I just don't need to add any routes. Typically, if you are creating a public subnet, in the public subnet route table you need a route for the internet and you add corresponding entry, but here you don't need that. However, you need to associate this route table with the subnet that you created, and that's what I'm doing. Okay, I have set up this left side. Let me quickly also launch EC2 instance in this subnet. So I'm just going with most of the things as default. I'm sure you know how to launch EC2 instance and how to connect to EC2 instances, so I'm not spending much time here. Select right VPC, select right subnet. I don't need a public IP. This is a private EC2 instance. I will go with the defaults. Let's add tag EC2 /a security group. Now here you need to think actually what security group you want to use. If you see this network diagram again, you need to ask a question on this EC2 from where you are going to receive the traffic. Now if you see, the traffic you are going to receive is only from this your corporate network, and the CIDR of corporate network is 10.200.0.0.16. That means ideally you should allow all the traffic from this network, right? So that's what I'm going to do. I'm going to not allow SSH, but I'll just allow all TCP, every port, but specifically from the CIDR range of my corporate network. I also should be able to ping from this machine to this machine, and that's where I'm also going to enable the ping protocol, that is all SCMP IPv4, and just using the same CIDR range on for the on-premise site. Let's launch the instance. It will take its own time. By that time we can just proceed and we can go to our next phase. setting up right side of the VPN connection, that is simulated corporate network. Now here I'm going to create another VPC in North Virginia region and one public subnet I'll be creating inside that. So let's go back to the console. This time let's go to the VPC but in North Virginia region. So I'm in North Virginia VPC console. Let me create a new VPC. Let's call it VPC B. Now we need different CIDR ranges here because then VPN connection need different CIDRs. Otherwise there will be an CIDR overlapping and then routing won't work. So here I'll choose 10.200.0.0/16, and as I need to create a public subnet, that means I would also need an internet gateway attached to this VPC. That's what I'm going to do next. Let's go to the internet gateway and create an internet gateway. Let's call it VPC-B IGW. Create, and once you create it, you need to attach it to your VPC. So I'm just attaching it there. Okay, next let's create a subnet. We want to create a public subnet. Let's give it a name, VPC-B public, and number 1 if you are going to create more subnets. Preference, let's give it AZA, and the CIDR range 10.200.0.0/424. Okay, one more thing on the subnet, ideally when we launch the instance, we also need that instance to have public IP, so we should enable this setting. Even if you don't do this, you can override this setting while launching the EC2 instance, but to be on safer side, if you forget, better enable this here. Next we are going to actually add a route table as well for this subnet. So let's create a public route table for VPC-B. Let's select the VPC. Now here we need to add a route for internet gateway because this is going to be a public subnet. So let's add a route 0000/0, route it through the internet gateway and save the routes. If you're not sure what I'm doing, probably you need to refer to my earlier videos about VPC basics. Let's associate this route table with the subnet that we created and just save this. So I have seen most of the time people forget to attach these subnets to the route table, and that's where the traffic does not flow as you expect. So make sure you associate the route table with the subnet. Okay, so we have set up the right side. We have set up VPC, IGW, public subnet. Let's also create EC2 instance in this subnet, which will act as our customer gateway. So right now I don't have any EC2 instance. Let me launch one EC2 instance there. Again, I am selecting all default. Here I'm just going with my VPC which I created. There is only one subnet and it would have a public IP enabled because I had set up the auto assign public IP settings on the subnet. Storage default tag, name tag, let me call it EC2B, which also acts as a router. Security group, again you need to ask the same question to yourself, from where the traffic is expected to come to this EC2 instance. Now if you look at the diagram, the traffic is only coming from here, right? Typically ICMP or any kind of TCP traffic. But additionally, I am going to log into this EC2 instance from my machine. That means we also need to open a SSH connection, at least for my IP address, right? So these are the two things we are going to add. So SSH from my IP, otherwise I won't be able to log in and configure OpenSWAN there. And here we'll go with the same all TCP traffic, but this time on the left side we have 10.100.0.0/16, which is AWS side of the CIDR, and I also want to enable the ICMP for ping. That's what we need. Let's review and launch the instance. Okay, so far what we have done, we are done with these two different VPCs. As of now there is no communication between these two. Next thing we want to do is create this virtual private gateway and then configure it for the VPN. Now in order to configure this virtual private gateway and a customer gateway, what we need is public IP address of this EC2 instance, because while you create a VPN connection, you have to mention where is your customer router, right? And that's where you need a public IP of this machine. So let me grab public IP of this machine, which is this router, and I'll just copy this address. Let's go back to our Mumbai region into the VPC console. Here you will see site-to-site VPN connection, but before creating this connection you need to create a virtual private gateway and a customer gateway. So let's create a virtual private gateway. Let's give it a name VPC A, VPC B, VGW, or you can just say VPC A VGW, that makes more sense. We'll go with the defaults. This is detached, you need to attach it to the VPC, so let's do that. By the time it gets attached, let's create a customer gateway, and as I said, here you will need a public IP of your side of the network. So let's create a customer gateway. Let's call it VPC B CGW. Now this is one place where people get confused. They think like customer gateway is AWS side of the entity. This is just a representation of your side of the network. So this is not really a AWS side of the network, it's actually a corporate side of the network, and that's where the IP address that we will be setting up is on the right side of this network, which is corporate network. So let's put an IP address which we just copied. We want a static routing. I'll explain more about the static and dynamic routing in different video. Rest of the things you can keep default and just say create a customer gateway. Now we have customer gateway, we have virtual private gateway. Now using these two, we can create a site-to-site VPN connection. So let's do that. Let's create a VPN connection. Let's call it VPC A, VPC B, VPN. We already have a VGW created. We already have a customer gateway created. Routing, we want static. We don't want dynamic routing as of now. Now this is an important step where you define the IP prefixes on the right side of the network. That means this side of the network, and that's where the VGW learns about, you know, what's the IP prefixes on the right side, so that when the traffic comes in for those, it will use a VGW to route this traffic to your corporate network. So here we need to put 10.200.0.0/16. Now that's the difference between static and dynamic routing. When you enable the dynamic routing, you don't have to provide all these routes. With BGP protocol, VGW will understand it dynamically, what are the CIDR ranges on the right side, and I think I'll talk about it later sometime in the next video. So that's what you have to put. Rest of the things you can keep default, or you can also set up some of these things on your own. Now something like pre-shared key. Now VPN create two tunnels for high availability, and the way VPN connection establishes is using a secure protocol, IPsec, and one of the process is to share a key between these two ends, and either you can set up your own pre-shared key, or if you do not, then AWS will generate this pre-shared key for you. We are going to leave it default, and we'll use the keys which are generated by AWS for both the tunnels. So that's it. Let's create a VPN connection. Now typically it takes around 2 to 3 minutes for this VPN connection to be available. By that time, let's log into this EC2 instance and configure OpenSWAN server there, so that we can configure it for the terminating our VPN connection. Okay, let's do that. For this I need a public IP of EC2B instance, which I got. Now what I need to do is go to my putty session and put this public IP. I need to select the right keys. For North Virginia I already have my key loaded. You would have to select your keys and just say open. Let me accept the connection. The default user is EC2-user. Okay, I am in EC2B instance. What I need to do is configure OpenSWAN. Now how to do that? I have listed all these steps in this document. I think I have already done most of this without referring to the document. Let me log into this box and do all these steps. So first thing, I need to change myself to root user so that I have full permission to install the OpenSWAN, and then I will just run this command to install OpenSWAN. Okay, done. Few things, you need to make sure certain files are properly configured. This is required so that IPsec service can pick the right configurations. So in the file ipsec.conf, make sure there is a line at the end which is not commented, so that we can add further files into this directory. This is already uncommented, so I'm not going to do anything here. Next thing, we need to update etcctl.conf. Now this is required because this machine is going to act as a router. It's going to forward what traffic it gets to the next the other machines in the same corporate network, and that's where we have to set these settings. We need to add a couple of lines here, which I have already listed. Somehow they all got onto the same line. They should be on the different lines. So let me just quickly do that. Okay, and after this is done, we just need to restart our network service so that all the changes takes into effect. Done. Now next thing, we want to configure our IPsec VPN. So far we just installed the OpenSWAN but haven't really configured it. We need to tell, right, what are the AWS side of the network looks like, what is pre-shared key and all those settings. Now from where do you get those settings? So all those settings on AWS side of the network, what we configured on the VGW, we get it from the AWS. We can download all these settings in the form of text file, and then we can use that text file to configure the OpenSWAN. So let's do that. Let's go to AWS side of the VPN connection. This connection is available now, and you can download the configuration. Now here, earlier there was no specific vendor specific, especially OpenSWAN related configuration exported by AWS, but now you can see OpenSWAN configurations are already there. Earlier there were generic setting, and then you would have to really pick the right values from this configuration, but now it is much more easier. So download this configuration file, save it somewhere. I'll save it maybe on the desktop. Just need to remember this name and close this. Now open this file in the notepad if you have. Let me go to notepad and open this. Okay, now this file is interesting. It talks about most of the things we already did, but more importantly it has tunnel details. So if you see, all these settings we already done. What next we have to do is create this file etc ipsec.d aws.conf. So let's do that. So I'm on EC2B machine, and let me create this file, and this file should have all the tunnel details. Now I would find this tunnel details here. right? So you just need to pick this complete block as it is, and you just need to paste it here. Now one thing is, these settings won't work as it is. There is this line which causes the problem for the VPN connection because auth ESP is not really supported. So what we need to do is delete this line. So make sure you follow this step, delete this line and save this file. Similarly, you also have to create aws.secrets file. So let's do that, which has a pre-shared key as I had told earlier. So let's do that and just put this entry here. That's it. So there will be two tunnels information in this file because as I said, AWS has two tunnels for high availability. So right now this is tunnel 1 details, and similarly there will be tunnel 2 details. But in this case we are going to only set up one tunnel. That's because OpenSWAN does not support having the two tunnels on the same host. For that we need a different machine. If we set up both the tunnels, the VPN won't work. Now let's talk a bit about this file. If you see, the left ID is actually the IP address of the customer side of the network, right? So if you see the EC2 instance, this IP comes from this, right, which is an OpenSWAN server machine, and the right side is actually the other end of the connection, that is AWS connection. Now from where you got this right side of the IP address, if you go back to your VPN connection and if you see this virtual private gateway tunnel details, you will see that there are two IP. Now these are the AWS side of the IP addresses. Because VPN always happens between the two public endpoints, and what AWS does is create two public IPs for you. So one of the IP you will see in tunnel 1, which is this, and other IP you will see in tunnel 2. As of now this tunnel status is down because we haven't really established the VPN connection. So let's do that. Similarly, there are this left subnet and right subnet. This is something you need to populate. Now left subnet is again the corporate network side of the network CIDR, and the right one is AWS side of the CIDR. So let's go back to our this file and modify these two values. So left subnet, if you can remember, left subnet is 10.200.0016, and the right subnet 10.100.00/16. Okay, so we are almost done with all our settings except one. If you see this diagram that we had, right, in this we set up this VGW or VPG. We have set up private subnet on this side, but one thing we forgot is we haven't really configured a route table of this subnet, which says if traffic has to go to this CIDR range, use this virtual private gateway. We haven't done that yet. Now how to do that? Let's go back to our AWS environment and let's go to our route table. This was our route table. Now here typically what you will do, you will just add a route here and then probably just configure it through the VGW, but there is other way to do this using route propagation. This is like automatically what are the right side of the CIDRs will be learned by your VGW and they will be propagated automatically. Now why this? Because tomorrow if some new CIDRs comes in on the right side of the network, you don't have to modify your route tables, they will be automatically propagated. So just say propagate and just save, and what you will see is after the VPN tunnel is up, you will see that entry populating here. Okay, so we are almost to the end of this exercise. Let's go back to our document. We have done all of these steps. we are done with setting up this IPsec conf files. We have set up the secrets file, and just we need to run this command to start our VPN tunnel. So let's go back to this VPCB and run this command, and just let's check the status of this IPsec tunnel, IPsec service, and it says it's running. Now how do we verify it's running? So one thing to understand is the VPN connection is always initiated from the customer end, not from the AWS side of the end. If there is no traffic flowing from the customer end, VPN tunnel goes down. So you need to make sure you are sending the keep alive bits or something to keep the tunnel up all the time. Okay, let's go back to AWS side of the VPN and see if you see the tunnels up there. So let me go back to site connections, and you see this tunnel is up now. And one more thing, we wanted to verify that in the route table, if you see this route getting propagated, not yet, but as the traffic will flow, you will see the route getting propagated here in the route table. Okay, so tunnel is up. The final test that we actually have to do is to see if we can ping this machine from this machine. We are already on this machine, so let's try to ping to this private IP address of EC2A machine. Now let me get the private IP of the machine, which is this, and let's go back to EC2B. Let me just clear the screen, and I'll just say ping this, and you see traffic is flowing with private IP of the machine, which actually means we have successfully set up the VPN tunnel between this AWS network and using this OpenSWAN router. So if you have done you could done up to this part, congratulations, you have already set up the VPN connection. Now in the next part of the video, I'm going to show some advanced routing where we would have another EC2 instance in another subnet, and then we should also be able to communicate with this instance using this router instance, right? Because this is now my customer end of the router, and in actual real life scenario, you would have a lot of servers on the right side, and everybody should be able to talk to this network through this router where we terminate the IPsec VPN tunnels. So if you have reached so far, congratulations. Just follow the document, and I'm sure you should be able to configure it on your own. One last thing I wanted to check, if routes are there. They are still not propagated. No, they are there now. It has been updated. So that's it we wanted to see in this video. Follow my next video for advanced configurations and advanced routing using this OpenSWAN router. Thanks for watching. Sorry, one last thing I forgot. If you are stopping here, make sure you terminate EC2 instances, and more importantly, you clean up your VPN connection. That's because you know, there is charge of $0.05 per hour for the VPN connections. If you leave the connection opens, you will unnecessarily charged. So make sure you clean up your resources accordingly. So that's it. Follow the next video. Thank you.